Welcome to Brain Vision.
We're told that when a light wave is emitted from an atom falling from its fifth excited state to its second excited state, it has a wavelength of 520 nanometers. So I called this wavelength lambda 5.2, and I converted it to meters. And then when it goes from the sixth excited state to the second excited state, it's 410 nanometers, which I converted to meters, and I called this wavelength lambda 6.2. And it wants us to find the wavelength when it goes from 6 to 5. So to do this, I'm going to use the fact that energy overall is going to be conserved from a cascade. So if if the energy levels go from 6 to 5 and then 5 to 2, that's going to be the exact same energy as going from 6 to 2. And energy is related to wavelength by the equation E equals hc over lambda, where h and c are just Planck's constant and the speed of light. So they're both constants. So I'm going to replace that in each of these cases. So we have hc divided by lambda 6.2, where we know the quantity value for lambda 6.2. And this is equal to hc divided by lambda 6.5, which is what we want to find. Plus hc divided by lambda 5.2, which we also know. So every single one of these values has Planck's constant and the speed of light in the numerator. So we can divide both sides by hc to cancel that out. So I'll go ahead and do that in red. And then we can start to rearrange this equation to solve for the wavelength lambda 6.5. So what we have here is 1 over lambda 6.5 is equal to 1 over lambda 6.2 minus 1 over lambda 5.2. Now all we need to do is raise both sides to the -1 to get lambda 6.5 out of the denominator and back in the numerator. So we raise both these sides to -1, and we plug in our value for lambda 6.2 and lambda 5.2 and carry out this expression, and that will give us our value for lambda 6.5. So if we go ahead and do that, we find that lambda 6.5 is equal to 1.94 times 10 to the minus 6 meters. 10 to the minus 6 meters is the same as 1 micrometer. So this is 1.94 micrometer, or 10 to the minus 6 meters. You could write it either way, but I'm going to write it as micrometers. We can box that in as the solution to our question.